All right, let's practice a little arc length here. Example 4, part A says graph r equals 2 minus 2 cosine theta, just for theta values from 0 to pi. So just doing that, let's plug in 0. When we plug in 0 for theta, we get 0 out. Let's plug in pi over 3. Yeah, pi over 3 would be a good idea for cosine. We plug in pi over 3, we get 1. Plugging in pi over 2, we get 2. Plugging in 2 pi over 3, we get 3. And plugging in pi, we get 4. All right, so since we are just graphing it from 0 to pi, we get half of a cardioid. All right, my friends, and then graphing it should help you to feel pretty confident about choosing your bounds for part B, where we find the length of the curve. So for part B, just using the arc length formula for polar form, we would need to know what dr d theta is.
Mama?
Yeah, buddy?
Can you go check the mole traps?
I think tomorrow, because if we catch any, we'll catch them at night. We have moles. All right, and then let's figure out, what's dr d theta? Wait.
2 sine theta.
Yep, and then do the legwork maybe for r squared. All right, and then plugging it into the arc length formula, so we would have the integral. I hope everybody, after graphing it, you'd be comfortable with the bounds being so straightforward from 0 to pi of the square root of what we got for the r squared expression. And then plus our dr d theta expression. All right, my friends. And then from there, looks like we could factor the 4 out as a 2. And then merge together the sine squared and the cosine squared. Those would equal 1, and then they'd merge with the one that's already there. All right, next we'll factor out the 2 as a square root 2. All right. And then this is the type of integral that leaves people staring at it, running through all of their nightmare experiences from chapter 7 and coming up still with nothing. So this is actually going to be a new move that we haven't demonstrated in this class yet. Let's see, maybe we should put, so then off to the side, before we can continue, let's talk about the power reducing formula for sine.
Pen's not as strong.
Did you see that frog up the air?
Okay.
Here we go. Okay. So if you remember, we're going to write this where the angle is called u. So sine squared u is equal to 1 minus cosine of 2u all over 2. And notice really quick, if you kind of look at the numerator here, it's a little similar to this radicand that we have over here in our integral. So let's isolate this numerator by doubling both sides. then to show off how we're going to use this, we are going to let u equal 1/2 theta. All right, and then if you rewrite that last line again, just replacing u with 1/2 theta, we'd have 2 sine squared of 1/2 theta equals 1 minus cosine of theta. All right, so what this does, just a little manipulation of the power reducing formula for sine, it gives us something to swap in for our radicand in our last answer, in our last step, that is. All right, from here, let's go ahead and square root everything that we have in there, since everything could, in a way, be a perfect square.
Should we bring out the
Yeah,
far real quick?
yeah, that one, right? Or do you want to jump there?
Oh yeah.
Yeah,
You know, I forgot about that. Okay.
Mhm.
Forgot which step.
Yeah, no. Very good. Now the square root 2's can merge together, and we end up with a factor in front of 4. And then you're left with something that you could use substitution on, or you could just kind of think through the chain rule in your head. There we go. And then just plugging in upper and lower bounds and simplifying as necessary. All right, so our final answer, my friends, is the arc length of that little half cardioid is exactly 8 units. Come on, that's adorable. Take care, everybody.